Good evening, students. Let us start discussing the previous year question paper on the topic of dynamic programming. Okay, so let us quickly see the problem and see the step-by-step solution. So we'll see the solution of 0-1 knapsack problem using dynamic programming. So this is the question that came in the winter 2024-25. Consider a knapsack bag where n equal to 4. The values profit are given by 10, 12, 12, 18 and weight 2, 4, 6, 9. The maximum weight is given by weight W equal to 15. The solution is to find the subset of the object that total value is maximized and the sum of weight of the object does not exceed the given capacity W. Implement and write the algorithm using dynamic programming strategy and derive the time complexity. So we'll see the step-by-step solution for this 10 marks question for dynamic programming and what the evaluator expect, how to write this question in the optimal time, what are the variations a question paper setter can have. So this is the question. So the background of this question is that if a thief is coming to your house and he sees n number of items with the weights and the values, he is carrying a bag of say 15 kg. He can either choose a item or ignore a item. That's why it is a 0-1 knapsack. So what item he should take so that value of the item selected is maximum. So let us, this will be the final solution that will look like. You will see a table. Okay, so in the X direction, the weight, and the Z direction, the number of items. Okay, and the selected items here, the selected items will be the I1, I2, I3. So this is also part of the solution. So let us see how to create this solution step by step. So first we need to understand the table structure. So we need to create a table. On the X direction, you have to start from 0 and up to the maximum weight capacity, that is 15 here. Okay. And then the J direction, okay, you have the jth item starting from 0, 1, 2, 3, 4. There are 4 items, corresponding weight and corresponding value. Weight are 2, 4, 6, 9. Value is 10, 12, 12, 18. So this is how you initialize the table. So this is the most important part. If you understand the table structure, half of the task is done in the dynamic programming. If you have any doubt, please ask in the comment section. I will be happy to help you. So the 0th item, there will not be any weight. So there is a dash and the value, there will not be any value associated. Next, we'll initialize this. So we will initialize the J equal to 0 as 0 and for X equal to 0 as 0. If the weight constraint is 0, you cannot take any item. So the value will be 0. Okay, so for X equal to 0, all the item will be 0. If you are choosing among the 0th item, so the total value will be 0. So that's why this is also a 0. So this is initialization. Next, we'll discuss how to fill up the table. Before that, what is the meaning of this table? So let us, this table called K, KJX denotes the optimal value of 0-1 knapsack problem with the first J items and weight constraint of X kg. So suppose you have an entry here. So you have to select out of first 2 items under the weight constraint of 6 kg. What is the optimal knapsack value? Suppose this is here. So out of first 3 items and the weight constraint of 13 kg, what is the optimal value of the knapsack? Okay. And what order we are going to fill up? We are going to fill up in this order. So first we are going to fill up the first column, X equal to 1. Next, we are going to fill up X equal to 2 in this down arrow fashion. Then X equal to 4 and so on till the last column. Okay, so followed by second last column and the last column. So this would be the order of filling of the table. We have already initialized, so let us fill up the first entry. So we'll fill up this using this formula kjx equal to max of kj minus 1x or kj minus 1 x minus wj plus vj if wj is less than x. So this is case 1 when you are telling that the jth item will not be a part of optimal solution. So it remains kj minus 1 x because you have not put anything into the knapsack. So the knapsack constraint remain x. In the second case, you are telling that the jth item will be included in the knapsack. So you have to, the sub problem will reduce to kj minus 1 you have to decide between j minus 1 atom. And since you have already included the jth atom in the knapsack, so knapsack back capacity will reduce by x minus wj. And you have to add vj to the optimal value if this wj is less than equal to x. So this is the meaning of this. So we'll just copy kj minus 1x means the copying from the up. So if the weight constraint is 1, so first we'll copy this here, we'll copy 0. The first atom itself, the weight is 2. So we cannot take the first atom. Okay. So now the next atom, the weight is 4. 4 is greater than 1. So 1 is less than. So we cannot, we will just copy 0 from the up, but we cannot update, we cannot include this second atom. Similarly, we'll copy this 0 and we cannot include the third atom because weight is 6, which is greater than the weight constant. Your allowed weight now is the 1 kg. Similarly, you will copy 0 from here and you cannot include the fourth atom because the weight of the fourth atom is 9, but your allowed weight is G1. Okay, so this entry is clear. So this will look like this after filling up. So for x equal to 1, okay, so you have the 0 copied from the up. Okay, so 0 will be copied from here up, and your weight of the first atom itself is 2. You cannot do anything, so it will remain same because you cannot include the first atom. Your weight constant is 1. Similarly, you cannot include, so 0 will be copied here. You cannot include the second atom because the weight of the second atom is 4, which is greater than weight constant 1. So it will remain 0. Similarly, here for the third atom, it will copy from the previous value 0. This signifies this. And you will try to include the third atom, but the weight of the third atom is 6, but your weight constant is 1, so you cannot include the third atom, so it will remain 0. Now for the fourth entry, you will copy from the top, that will 0. You try to include the fourth atom, but the weight of the fourth atom is 9 and the weight constant is 1, so you cannot include the fourth atom and it remains 0. So your entry will look like this. Now we are going to fill up for x equal to 2. So we'll copy from the top. So this becomes 0. So this signifies this. And we'll try to include this. So this is case 1 and this is case 2. In case 2, we'll try to include the item. So we'll try to include the item 1. Its weight is 2 and allowed weight is 2. So we can fit this item under the weight constant 2. So what we will see, will go 2 minus 2 is 0. So we'll see this value and plus we'll see this values, this in the previous row, j minus 1th row, and we'll see the this entry. So 2 minus 2 is 0. 0 means 2 is step back we have to go. So this entry. So basically this entry plus 10. So this is nothing but k 0 0 plus 10. So maximum of 0 and 10, that is 10. So this will be updated as 10 here. Now we'll copy back again 10 from the top. The current atom weight is 4, which cannot be accommodated again in the weight capacity of 2. So there will be no update in this value here. Next, we'll copy the 10 from the top. The weight of the current atom is 6, whereas the weight constant is 2. 6 cannot be accommodated under the 2 kg. So there will not be any update. Similarly, the next entry is 9. 9 cannot be accommodated under the back capacity of 2 kg. So we'll just copy the 10 and there will be no update in the second row. So this completes the second row. Similarly, we'll fill up the entry for the 3. So we'll copy this 0 here and the allowed weight is 3. Weight of the second atom, first atom is 2. Weight of the first atom is 2. So 3 minus 2 equal to 1. So we'll go into the j minus 1 row and the weight 1. So that is 0. 0 plus 10. So we'll update this value with the 10. Okay. So you can either see it as a going 2 step back if the weight is the 2 in the one previous column in previous row and going 2 step back if the weight is 2. Or you can directly calculate 3 minus 2, 1, and you can go the 1th column here. And it's updated as 10. Now similarly, we'll copy the 10 here. The next item weight is 4, but the allowed weight is 3, so it cannot be considered. So 10 will remain and there will be no update. Again, for the next row, the 10 will be copied from the top. The current item weight is 6, but the allowed weight is 3, so it cannot be included. Hence, there will be no update here. Proceeding to the last items, we'll copy the value from the top. The current weight of the item is 9, but allowed weight is 3, so there will not be any update because this item cannot be included. So this completes our the x equal to 3, the column x equal to 3, and it looks like this. Similarly, we are going to fill up for x equal to 4. So can you pause and fill it yourself and then verify so that you understand how to update? Okay. So let us quickly fill up for x equal to 4. First, as discussed, we'll copy the value from the x equal to 4. So it will be 0 here, and this will be updated as 10. 4 minus 2, 2. So this value plus 10, 0 plus 10, maximum of 0 and 10 is 10. So it will be updated as 10. Next, 10 will be copied here. This current weight of the item is 4 and the allowed weight is 4. So this item can be considered. So 4 minus 4, 0. So you go into the previous row and the 0th entry. Okay. So 0th entry. So this is 0. 0 plus 12. So maximum of 10 and 12 is 12. So we'll update 12 here. So let me repeat. This 4 is less than equal to 4. So this item can be included. So we go into the one previous row and 4 minus 4 is 0. So we go here, 0 value we pick up, add with the current value 0 plus 12, 12. So previous value was 10 and the new value is 12. So maximum of 0 and 12, that is 12. So we'll copy the 12. We'll update this entry with the 12 here. Next, I will copy the 12 in the next row. The weight of the current item is 6, allowed weight is 4. So this cannot be considered to include. So there will not be any update here. Similarly, we go to the next row, copy this 12 from the top. The weight of the current item is 9, the allowed weight is 4. So this item cannot be considered and hence there will not be any update. So this completes the filling for x equal to 4. So did it match your filling? Have you tried? If not, you can try for x equal to 5. So this will look like this, x equal to 5, and match the result so that you also understand the way we are filling up the table. How we are filling up the table? We are copying the value from the top. 0 is copied from the top. The allowed weight is 5. The current weight is 2. So of course this item can be included. 5 minus 2 is 3. So this will go to this here, one previous row, third entry. 0 plus 10. So this will be updated as 10. Next 10 will be copied to the row. Item second weight is 4, but the current allowed weight is 5. So this item can be considered. 5 minus 4 equal to 1. We go to one previous row here and 1, we get the value 0. 0 plus 12 is 12. Maximum of 10 and 12 is 12. So this entry becomes 12. Next 12 is copied in the next row. 12 is copied in the next row. Okay. So the current item weight is 6. However, allowed weight is 5. So there will not be any change here. Similarly, we'll copy the value in the next row 12. And the current weight is 9, but allowed weight is 5. So it cannot, this item 4 cannot be included, and there will not be any update in this value 12. So this completes our filling for the x equal to 5. I hope you understood the process. Similarly, let's fill up the value for x equal to 6. So we'll, as discussed, we'll copy the value from the top 0. Current weight of the first atom is 2, which can be included because it is less than 6. 6 minus 2 is 4. So this value is 0. 0 plus 10, 10. The maximum of 0 and 10 is 10. So 10 is updated. Next 10 will be copied here. Now for the second item, weight is 4 and the allowed weight is 6. So it can be included under the weight capacity or weight constant of 6. 6 minus 4 is 2. So we'll go into the previous row and the value in the column 2. So this is 10. 10 plus 12 is 22. Maximum of 10 and 22 is 22. So we'll update here by 22. Next, we'll copy the 22 here. Our current weight is 6. Current item weight is 6. Allowed item weight is 6. So 6 minus 6 equal to 0. So we'll go to the previous row and the 0th entry. So this is 0. 0 plus 12, that is 12. But the current entry is 22. So maximum of 22 and 12 is 22. So 22 remains here. Similarly, we'll copy the 22 in the next cell. So the current weight is 9, but the allowed weight is 6. So this item cannot be included, and hence there will not be change in this entry. So this completes for x equal to 6. Can you complete this 1 or 2 entry and match the results? So similarly, we'll get for x equal to 7. The 0 is updated as 10 because this is 7. So 7 minus 2, that is 5. So previous entry 5, that is 0. 0 plus 10, it is updated as 10. Now the current weight is 4. The allowed weight is 7. 7 minus 4, 3. So we go to the previous entry and the third item, that is 10. 10 plus 12, 22. It is updated as 22. Now the allowed weight, will copy the 22 here. The allowed weight is 7. Current weight is 6. 7 minus 6, 1. So we go to the previous entry and the 1, that is 0. 0 plus 12. 12 is less than 22. So 22, there will not be any change in 22. For the next item, the 22 is copied. 7 is less than 9. So this item will not be considered. Hence, there will not be any update in the 22. So this completes for filling x equal to 7. Next, we will fill similarly for the x equal to 8. We'll copy the value 0 from the top. 0 is updated as 10 because 8 minus 2 is 6. 2 is less than 8, so it can be included. 8 minus 2 is 6. So for the sixth entry, it is 0. 0 plus 10, that is updated as 10. For the second item, the weight is 4. 4 is less than 8, so it can be included. 8 minus 4 is 4. So we'll go to the one previous row and the fourth column, that is 10. 10 plus 12, 22. 22 is greater than 10, so 10 is updated as 22. Now for third item, the current weight is 6 and the allowed weight is 8. So 6 is less than 8, so it can be included. 8 minus 6 is 2. So we'll go to the second column of the one previous row, 10. 10 plus 12, 22. So this the both the value are 22. So whether you include this or do not include this, the knapsack optimal knapsack value remain 22. You copy the 22 from the up and you see the current item weight is 9 and the allowed weight is 8, so you cannot consider the current item, so it remains 22. This completes the filling for x equal to 8. Similarly, we will fill up the x equal to 9. So we copy the 0 from the top. This is updated as 10. Okay, so for the second entry, this is 4, this is 9. 9 minus 4, 5. So we go to the one previous row and the fifth column, that is 10. 10 plus 12, 22. 22 will be updated in place of 10. We copy the 22 here. Okay, 9, this value is 9, this value is 6. So this item can be included. 9 minus 6 is 3. We go to the one previous row and the third column, this is 10. 10 plus 12, 22. So same value. So we can choose either of this. So this remains 22. Now for the last entry, the item is 9. The current item weight is 9, allowed weight is 9. So this item can be included. 9 minus 9, 0. So you go one previous row and the 0th column. So this is 0. 0 plus 18, 18. The from the top it is 22. Maximum without including this current item, the knapsack value is 22. So maximum of 18 and 22 remains 22. So this remains 22. So this completes the filling of x equal to 9. Similarly, we'll fill up the x equal to 10, 11. Okay, so let us discuss for x equal to 11. So we'll copy the 0 from here, top. Now this current weight is 2, allowed weight is 11. So 11 minus 2, 9. So that is 0. 0 plus 10, that is updated as 10. The second item, the current weight is 4, allowed weight is 11. 11 minus 4, that becomes 7. So we go to the up entry, one row, and we got the 7. 10 in the 7th column, 10 value. 10 plus 12, 22. So 22 will be 22 will update the 10. So 10 will be updated by the value 22. Next, we copy the 22 here. The allowed weight is 11. The current item weight is 6. 11 minus 6 is 5. So we go one row up and the fifth column, that is 12. And 12 plus 12 become 24. So 22 will be updated by 24. Next, we copy 24. Allowed weight is 11. Current weight is 9. 11 minus 9 is 2. So we go one row up and the second column, that is 10. 18 plus 10 is 28. So 24 will be updated as 28. Similarly, we are going to fill up the 12th column, x equal to 12. Okay. So the first entry will be copied. Allowed weight is 12. current weight is 2, 12 minus 2 is 10. We go to here, 10th column, plus 10, 0 plus 10. So 0 will be updated as 10. 10 will be copied here. Allowed weight is 12. Current weight is 4. 12 minus 4 is 8. We'll go to the one row up and the 8th entry, that is 10. 10 plus 12, 22. So 10 will be updated by 22. We copy the 22 here. Current item weight is 6 and the allowed weight is 12. So 12 minus 6 is 6. So we go one row up and the 6th entry, that is 22. 22 plus 12, that gives us 34. So 22 will be updated by 34. We copy the 34 here. The allowed weight is 12. The current weight is 9. So 12 minus 9 is 3. So we go to the third column in the one previous row, that is 10. 10 plus 18 is 28, which is less than 34. So the value is not updated. So similarly, we fill up the x equal to 13 and x equal to 14 and x equal to 15. So this value, the last value, is our optimal knapsack value, that is 34. Okay. So now we'll backtrack and find out which values are included for the optimal value of 34. So coming back here, there is no change. We just copied from the top. So this we are not included this item. Okay. So this we have not included the I4 item. So now this value is updated. So I3 item is included. Okay. And this update is coming from which? 15. 15 minus 12, that was 3. So this update is coming from the 3. So the 15 minus 12. So this update is 15 minus 6. The weight is 6. So 15 minus 6, 9. So this is coming from this 9th entry. Okay. So here you can see that there is update on this entry also. So the item 2 is also included. So this item value is coming from the allowed weight is 9 and the current weight is 4. So 9 minus 4, that is 5. So this is coming from this entry. So and you can see that there is a change here. So item 1 is also included. So the item included becomes I1, I2, I3. So this is the complete solution for this particular numerical. Next, you have been asked as to write the algorithm. So this is the algorithm. 0, 1 knapsack, it takes the maximum weight capacity, number of items, respective the weight array and the value array. You initialize the knapsack x0 equal to 0 for all x0 to w. Similarly, k0i for all i0 to n, you initialize this. Then for x equal to 1 to w, for j equal to 1 to n, you fill up kxj equal to kxj minus 1. You copy the value from the top. If wj is less than x, then you will calculate kxj equal to max of kxj, the current kxj, because this is copy of this, and kx minus wj, j minus 1 vj. And finally, return the last value kwn. You can maintain another array to denote which items you are included, or you can do the backtracking to find which item you have included. So what will be the time complexity? So this is the initialization. The major time is spent is in the loop, X loop and the J loop, and they are dependent loop or independent loop. They are independent loop. So this is running for W times. This is running for N times. So the total time complexity will be N into W. So this is the time complexity of this algorithm. What is the space complexity? Since you require a table of N into W to store the value, so space complexity will be N into W. What if you are told to optimize the space complexity? Since at a time you need only one row for the calculation or the 2 row for the calculation. So optimized space complexity will be OW. You don't need the complete table for the calculation. At a time, you need only one previous row for the update. So this completes the time complexity. Summary, we have discussed the problem using the dynamic programming, optimal substructure that will be asked, the recurrence relation, so of algorithm pseudocode, time space complexity, and table filling. So optimal knapsack value that we got is 34. The item included I1, I2, I3, I4. Time complexity was NW. Space complexity was order of W, optimized space complexity. So if they ask the optimal substructure, recurrence relation, algorithm, and time complexity, first fill up this and then try to solve using the table and the backtracking if it asks which are the item included or what are the decision choice that are included in the optimal. So how they may ask the variations of the question. They may ask to define the problem. they may ask that tell what is the optimal substructure here, how the dynamic programming is used in this particular algorithm, and they will always tell for a particular numerical to solve this problem. Okay, so I hope you have understood this dynamic programming very well. If you have any doubt, any specific query, please write in the comment section. If you want the solution of any other topic, just mention the topic name. I will try to discuss the solution in the upcoming video. In the next video, we'll discuss the longest common subsequence, which is another dynamic programming algorithm, and we'll try to discuss with these questions which has come in the winter 2023-24 at VIT Vellore. So thank you everyone. I hope you have understood the algorithm completely, and you will be able to solve it in the exam. So if you have any questions, any query, please write in the comment. Please share, subscribe to the channel, and share with the friends if you like the content. Thank you everyone.